Okay, this is just a bit of interest. We've got a lot of aeroplanes around today, so I might have to stop and start. But this is the inside of a kiln, and it's a 12 kilowatt kiln. And if you notice, you've got elements down one side, elements down the other, and some at the bottom. There's none at the back and none at the top. So we'll just have a look at the label. It's sort of interesting, and I wondered how these were wired up. So that's what this video is about. So here we go. I don't know whether you can see these numbers, but it's 12 kilowatt and it says 3-phase and neutral, and it's 20 amps per phase. Now I know you can wire these either 3-phase or single phase, but of course on single phase it's hell of a current, yeah, because it'd be 3 times 20, so there'd be 60 amps, but it might not be quite that amount depending upon the single phase voltage. But there you go, max working temperature 1300 degrees. Okay, so we've got that. Let's go and have a look at how it's wired up. Okay, this is the back, and if you could see, there's all those connections. So the element, that's connections to the elements. So look, that's a series connection there. Then that is effectively either end of a coil, and then a series link, and then another coil and a series link, and it goes on until there's a connection. Okay, so if we look down here at the end of these series of coils, we have got 2 wires going to one connection. That's the neutral. Yep. And then that next wire is another phase, which then goes around this lot. So we go there, that's it. There's the really rough and ready, a contactor block, and then it comes up here, and that one there is a neutral. Yeah. And then it goes up the next one. So in this case we've got 3 lots of connections, and that's a live there. I think we'll have to draw this out in a minute, but I couldn't believe how sort of easy it was. So let's just have a look at this contactor block, because that again is dead rural. I mean, whether or not the contactor has been changed at some part in the past. And the engineer went, do you know what, I can't be arsed to do this. Let's just dump it in the corner here. So we got some piddling small wires. That one there goes to the pyrometer. This grey wire goes off to the controller. So all the controller does is switches this contactor on and off. There's no sort of fine sort of will only run 1/3 of the coils or something like that. It's like all or nothing. So I think what we need to do now is just zoom down on this. So we got the 3 phases out of the contactor and the neutral, and of course the neutral then goes off to several neutrals, and then we've got 3 phases in plus neutral. So this thing just switches on and everything's on, and then the controller switches it off and on and off and on and off. So this wire here from the controller obviously takes 240 volts, so off one of the phases up there to the controller, comes back as a control for this coil, and it also has the pyrometer, and we got an aeroplane. Okay, let's see if we can make any sense of this. We have a live there. Yeah, that goes through a coil to a link, to a coil, to a link, to a coil. 1, 2, 3, 4, 5, 6, 7. Okay, 1, yeah. 1, 2, 3, 4, 5, 6, 7 coils. Okay, that's a neutral, and that neutral comes from the contactor. Okay, then you've got another trail of 7, so let's just do that. Okay, so that's 7 and that's 7. Okay, and that neutral goes to there. Yeah, and then you've got another load of 7 there, 7 coils, and that is alive. And then this one here is alive also, so therefore you have your 1, 2, 3 separate bits of 240 volts, because with 3 phase you have 415 volts or 420 volts or 380 volts between any phase, between any 2 lives, but between any live and neutral you have 230 or 240 volts in the UK. Okay, so that is that. So if you wanted to adjust this, say you wanted to run it on single phase, well, effectively this is 3 lots of single phase, so you would have to wire it so that these 3 were in parallel. Have we got space somewhere? We probably have. We got 1 coil, another coil and another coil, and you'd wire them like that across a single contactor, right? But that's a huge amount of current. You could cut one out, yeah. So instead of, say these are 4 kilowatts each, yeah, so you cut one out, which is probably the bottom one, then you have 8 kilowatts instead. But you could also be a bit circumspect and change things. If you change that neutral there to add in another 2 sets of coils, so instead of 7 it'd be 9, the resistance would increase, and therefore the wattage of that would be less. So you could increase that to 9 and that to 9 while ignoring that, yeah. And the way to work out the wattage of that is the volts squared, so i.e. the volts multiplied by itself divided by the resistance. So you'd have to measure the resistance of that circuit with your multimeter, or the resistance of an individual coil, and that could be something like, I don't know, 5 ohms or 13 ohms. 3 kilowatt at 240 volts is about 19, so you're gonna have to work that one out yourself. But go and have a look at the ohms wheel, or I'll put a link here to the various videos I've done about Ohm's law. So let's just do a bit of this arithmetic whilst we're here. So volts squared divided by resistance equals watts. That's one of the calculations. Now I measured across those series of elements, and I measured it on the contactor, and we had 15.8, 15.8, and then a weird one, 12, no, 11.6. So obviously one of those series of elements is going to draw more current. So we've got, say, let's say for instance, can we see the calculator? That's probably a bit better. Let's call it 240 volts, just for argument's sake. Squared is times 240 equals, and then we divide it by 11.6. That's nearly 5 kilowatt, 4,965. So that is 5 kilowatt. I'm starting to think, yeah, thoughts about this. So where are we? I should have kept that number. Never mind. 240 times 240 equals, that is 57600. Right, and then we divide it by 15.8 equals, that's 3,645. 3,645 watts. So 3.6 kilowatt. Okay, now can you see where I'm coming to here? So let's go 15.8 divided by 7 equals 2.23. No, 2.3. That'll do. Okay, so we've got 2.3 ohms per as an average per element. So if we had 9, 2.3 times 9 equals, that's 20. Well, that's about 3 kilowatt, because as I say, an immersion heater at 240 volts is 3 kilowatt, and it's about 19 ohms from what I remember. But let's do the arithmetic. 57600 divided by 20 equals 28. So, you know, nearly 3 kilowatt. So 7, no, what was it? 9 elements equals 2880 watts. Can you see how if we used 2 lots of those, 2 banks of those elements, we can shuffle things around and get whatever wattage we want. So effectively, if we use 2 banks, we're not far short of 6 kilowatt. So if we had 10 at 2.3 is 23. Yeah, so 10 elements. So again, we got 57600 divided by 23 equals 2.5 kilowatt. So if we had 2, it'd be a 5 kilowatt kiln. Interesting that one can mess around like this. Obviously, I mean, what happens is, I think that controller, it's got a pyrometer attached, and you can program it for the rise in temperature. So if you had less elements or 2 banks of elements attached with more elements per bank, then, and it's running at say 5 kilowatt, then it will be on slightly more, but the draw on the supply would be a lot less, because at 5 kilowatt the draw, and it's 4 amps per kilowatt at 240 volts, as near as, yes, equals 20 amps. So how many elements would we need if we wanted to draw 15 amps? Okay, so let me think about this. So 9 is 2.8, 10 is 2.5, and we at 15 amps is, it's where is that? 13 amps is 3 kilowatt, so 15 amps is something like, well, it's 3.5 kilowatt. Okay, so to be able to get 3.5 kilowatt, we want to divide that by 2. That's 1.5, 1.75, 1.75 kilowatt. So we want to reduce that a bit more. And we could do some clever maths, or we can just guess. If we had 12 elements, all right, so 12 times 2.3, can we still see this? That's 276. 276, right, okay. So we got 57600 divided by 27.6 equals, well, that's 2 kilowatt basically. So to get, so at 4 kilowatt, right, so 12 equals 2.086 watts. That's 2 kilowatt. So we'd have to have maybe 13 elements to get down to 3.5 kilowatt over 2 banks. And it's just on for longer, but the draw on the supply is less. I didn't realise that these kilns could be this flexible. Nice one. So there you go. So now the only thing I want to cover as well, and let's hope we've got a bit of space, so let's just here on the contactor on this one, it's obviously a contactor with 3, actually it's got 4 because it's got a neutral, yeah, it's got 4 sets of contacts, yeah. So now I've drawn that wrong really, but let's put them here as well. So this is the inside, so you have the 3 phases at 240 volts plus the neutral. That's the supply side, and the other side obviously is, so when the contactor pulls together it connects that to that, that to that, that to that, and that to that. So on this one we have that grey wire, so we have a neutral going off, and on this case it's a live that goes off to the controller, yeah, and then that comes back from the controller is a live, a switched live and a switched neutral, and they go to the coil of the relay or the contactor, yeah. And then in amongst that grey wire you've also got 2 wires for the pyrometer, and it really is as simple as that. And I'll just show you the controller that is with that kiln, just as a matter of reference. So here you go. Wrong way up, that'd be better. And the There is a bit of a manual with this, but doesn't say anything about wiring this plug up, which has 8 connections. So we got a live and neutral in, a live and neutral out, an earth, that's 5. We've got 2 for the pyrometer, which leaves 1 more. So that probably wants investigating. But running a ceramics kiln on electricity is a bit sort of, nowadays with electricity at 50 pence a kilowatt, you'd have to be quite careful. I think you'd have to detune this, but there's a potter on YouTube, Simon Leach, who shows how relatively simply you can convert an electric kiln to a gas kiln. You need plenty of kiln shelves to create a serpentine flame path or heat path, and then you have to create a port in and a port out, one for your gas flame and the other one for a chimney. But anyway, I'd love to hear comments about this, yeah, and other people's thoughts, and I will catch up with you soon. Cheers for now.